Hello dear students, let us start the next concept on the Bayes theorem. This is very important concept. So Bayes theorem is one of the most important concept. Now we are going to learn it. If you know the total probability, then the Bayes theorem is very easy. Just for example, in my previous lectures, I explained about the auto, train, bus. Okay, that one problem I explained. In that, what is there? A person is traveling from the home to office by auto, bus and train. By train he is reaching some probability late. By auto he is reaching some probability late. By train is reaching. By car is reaching some probability late. Then if I ask you specifically, because of car he is reaching late. If I specify that because of car is coming late, what is the probability? Because of car is coming late. So at that time we use the Bayes theorem. Okay, for example, one more question if I want to say. In the previous lecture I explained about my recent lecture I explained about the candidate who is contesting for the MP seats. Okay, four candidates are there. They are contesting for the MP seats, and if A wins, he introduce a policy. B wins, he introduce the same policy in this probability. If C wins that, and he will he will introduce a policy in this probability. They said as 0.8. If A wins, 0.5 probability. If B wins, 0.1 probability. If C wins, 0.4 probability. If D wins, 0.1 probability. Like that they have given in the previous lecture. So if I specify that because of a person B or because of a person C, because of a person D, the policy is introduced. If I specify that because of this person this happens, that is called Bayes theorem. So total probability depends on that. Suppose total probability, I told you that E1, E2, E3, E4, so and so En are mutually exclusive events. E1, E2, E3, E4, En, so and so En are mutually exclusive events and exhaustive events. Exhaustive events means what? E1 union E2 union E3 union so and so En, that is equal to S, and these all are exhaustive events, and if they are mutually exclusive events, probability of A associated with E1, probability of A associated with E2, probability of A associated with E3, En, so and so, then probability of A will be probability of E1 with A plus probability of E2 with A and probability of E3 and A, like that. Likewise is there, right? Okay, this should be intersection. Okay, probability of En with A. So what is we will write as probability of E1 into probability of A when E1 already happened, plus probability of E2 into probability of A when E2 already happened, so and so probability of En when probability of A when En already happened. This is the total probability. Now if I specified as some person, suppose I said A, B, C, D. So A person is this because of the A person it happened, because of the B person is happened. So B person will come on the numerator and total probability will come on the denominator. That is what the Bayes theorem. Bayes theorem said probability of EI when A already happened is probability of EI intersection A upon probability of A. This is what we called as Bayes theorem. This is what we called as Bayes theorem, also called as reverse probability. Reverse probability we call, where I is equal to 1 to n anything. Okay, so what I want to say here, because of A it happened. If I say that is the car, because of car is reaching home late, so car probability, like suppose here this one is their car related, this is suppose this is about bus, a train, this is about car, likewise you have. Okay, so if I want to know what is the reason to get by car late, so car should be on the numerator and total probability should be in the denominator. Total probability of A is the total probability. Probability of A will be the denominator, and relate the event happened by car or event happened by bus, event happened by because of person B, that will be on the numerator. Means only specific this one will be in the numerator, rest total probability will be in the denominator. That is what we called as Bayes theorem. Students, with an example we will make you understand this. I'll just give you an example so you will understand easily this concept. Okay, just wait an example, I'll explain it. Let us discuss this problem and make you understand this one with the example. I'm dictating the problem, you note down. in a city, in a place, in a particular area, three candidates are the contesting for the MP seat. Okay, so probability of winning A is 0.5, probability of winning B is 0.3, probability of winning C is 0.2. Probability of launching, say if A wins, launching the new policy is probability of launching the new policy. If A wins, probability of launching the new policy is 0.8. If B wins, launching the probability of launching the new policy is 0.3. If C wins, probability of launching the new policy is 0.7. I repeat again. In a particular place, three candidates are contesting for the MP seats. Okay, probability of winning A is 0.5, winning B is 0.3, winning C is 0.2. And he's saying that a policy is introduced by, if A wins, he introduces a new policy, the probability of launching the new policy by A is 0.8. The probability, if B wins, then he will launch the new policy, that is 0.3. Probability of if C wins, then that is 0.7. If policy launched finally means somebody is win. Find the probability that it was launched by B. So now specifically saying about this is specifying that because of B, the policy was launched. So these cases we will use the total probability, Bayes theorem. So let us see a probability of B. Okay, probability of B when a policy is happened because of B. B by E, probability of B by E is equal to probability of B intersection E upon probability of E. So here probability of E is nothing but total probability. This is the formula of total probability. Probability of E is equal to what? Probability of E is equal to what? Probability of A into probability of A when E already happened, like this, right? Probability of E when A already happened, probability of E when A already happened, plus probability of B into probability of E when B already happened, plus probability of C into probability of E when C already happened. This is a total probability formula. This is I explained in the previous lecture. In that I took the 4 candidates. Here I took the 3 candidates. So probability launched by the B, probability that is launched by B, probability that the new one launched by B, that is B by E, is equal to, that is I can write as B part should be on the numerator and total things will be in denominator. So total things here what is here? 0.5 into E by A, that is 0.8 plus, now here 0.3 into E by B, that is 0.3. Look at there. E by B is 0.3. Probability of C is 0.2 into probability of E when C already happens, 0.7. And here is said specifically about B. So B should be, only this B should be coming on the numerator. That is the answer. That's it. Simple. If you know Bayes theorem, then total probability is done. Is specified with whom, that should be getting on the numerator. That's it. The final answer will be getting here. So just you have to simplify this and you are going to get the answer. This is what what we call as Bayes theorem. Okay, hope you all understand this. This is how much you got, 0.63, this multiplication. So 0.60, so 0.3 into 0.3 divided by 0.63 you are getting. Okay, if you multiply, add, 3 3s are 9, 8 5s are 40, 40 plus 9, 49, 49 plus 14, that is 63. So 0.63 you are getting. Okay, so 0.003, 0 point that into upon 0.60, this is your answer. You can simplify this one. Okay, this is anybody can be do. Okay, that is not a big issue, right? Here, dear students, is it clear to you all? I hope it's clear now. So if you simplify this, you are going to get the answer. So that is not a big issue. Now if I change a question that if the probability it was not launched by C, if somebody asks you, so what is the probability that it was launched by B, means this is the way we will do it. If the same question is asked, if that is the probability that it was not launched by, so it was not launched by C, if they have like this, don't do this thing. What is that? Don't do that. What is that? Minus. Don't do that. Don't find the probability of C upon E and don't do minus. That answer, this answer will not be equal. Okay. What you do for this one, what I want to say here, probability of C when E already happened, you will find this one. Probability of C upon, by using this, means what you will do in this case, we just take the 0.2 into 0.7 up, so you are going to get the answer. So you will get this answer when it is launched by C, but not launched by C, 1 minus, you should not use this. You should not use this in this case. That I want to specify you. When you have not launched by this, then you have to do in different method. What is the different method you have to approach? That I'll tell you now. Okay. So if it is not launched by C, then you have to go another way, another method I will explain you now, and let's solve some more examples based on this. Now here you can see, dear students, now if policy launched finally, find the probability that it was not launched by C. If it is not launched by C, what we will write as probability of C is upon E bar, because not launched, E is launched, E bar will be not launched. So therefore probability of C intersection E bar upon probability of E bar, you will get the answer for the Bayes theorem. It is not launched by C, it is not launched by C, that is we can write as probability C upon E bar, that is probability of C intersection E bar upon E bar. E bar means E is what? Launched. E bar means did not launched. Okay, so probability of E bar will be, we can write as 1 minus probability of E. Okay, so probability of E already you know, probability of A into this is, you know, probability of A into probability of E by A, probability of B into probability of E by B, probability of C into probability of E by C. By using this you can find it. It means from this you are going to get how much? 0.5 into 0.8, 0.5 into 0.8, plus then what you get here, 0.3 into 0.3, 0.3 into 0.3, plus this, from this what I am going to get here, 0.2 into 0.7. If I multiply 0.85 is a 40 plus 0.33 is a 9 plus 0.14, if I add this one I get a 0.63. 0.63, sorry. So 0.63, that is the probability of E. If I say probability of E bar, denominator I am speaking. So probability of E bar will be 1 minus probability of E, that is can be written as 1 minus 0.63, that is 0.37. Okay, probability of E bar you got, 0.37. This is one method of finding the E bar. But another way is probability of E bar can be written as probability of A intersection E bar plus probability of B intersection E bar plus probability of C intersection E bar. Okay, so association of E bar without happening A with A, B, C. So probability of A into probability of E bar upon A plus probability of B into probability of E bar upon B, probability of C into probability of E bar upon C. So probability A given, B given, C given. E bar means what here? 1 minus 0.8, that is 0.2. 1 minus 0.3, that is 0.7. 1 minus 0.7, that is 0.3. So that is you are going to substitute here. So probability A already there, B already there, C already there. So probability of E bar upon A will be how much? 1 minus 0.8, that is nothing but as 0.2. Okay, probability of E bar upon B will be how much? 1 minus 0.3, that is equal to 0.7. Probability of E bar upon C is how much? Probability of E bar upon C will be 1 minus 0.7, that is equal to 0.3. See, did you understand or not? I don't know. You just do the comment or you just send me message. Probability of A is this, probability of B is this, probability of C is this, E upon A. That was the previous question. Now what was the question changed? It is not happened by C. Means this is not launched by C. So E bar is coming with C. E bar with C. So what we are doing, the problem is, the formula is this. So probability of E bar can be find two ways. Probability of E bar, no problem. You can by this way you can find, or you can find by this way. So you have this probability of E by A, then E bar by A will be 1 minus this, E bar by B will be 1 minus this, E bar by C will be 1 minus that, and that can be substituted in this. So you are going to get this answer and this answer will be same. So there is no problem, that is getting 0.63 in the denominator. Okay, denominator is fixed. Now only numerator I have to solve. So numerator what I will get? Numerator I will get this, because this one, these are the two independent events, mutually exclusive events. So this can be changed, this one. So this can be here we kept. So that will be the final answer. Either you can use this way, either you can use this way. That is the both options I gave you. Probability of A is what here? 0.5, and probability of E bar A is what here? 0.2. Okay, probability of B is what here? 0.3. Probability of E bar by B, how much? Probability of E bar by B is how much? 0.7. Probability of C is how much? 0.2. Probability of E bar upon C is how much? Probability of E bar upon C will be 0.3. This is I done here, there. So just you can say 0.2 into this, that is 0.10 plus 0.21 plus 0.6. So if you add this one, I will get as 0.21, 31, 37. So I got 0.37, 0.37. So that is, this is same. So you should know these both things. You can use this formula or you can use that formula. So I got this one. So this formula I am going to substitute here. I am going to find that when it is not launched by C, not launched by C will be probability of C into probability of E bar divided by C upon probability of E bar. So that is probability of E bar is this total. This is the probability of E bar, and we have already find what is the probability of E bar in two methods. So now you can substitute in this. I am going to get the final answer here. Probability of C into probability of E bar by C, that is how much I got? 0.2 into 0.3 divided by, this is I got 0.37. This is the way we can solve this problem, and you are going to get the answer. So this is what we called as Bayes theorem. Let's solve many questions based on this. Few more questions we can solve that, so you can understand this concept. That is my intention, is you need to understand the first concept. If you understand the concept, all the things will be clear out. Okay, if you did not understand, then it is a problem. Okay, so the answer is how much finally? That is 6 by 37 is the answer, correct? So 0.6 upon 0.37, this is can be written as 6 by 37 is the answer. Okay, hope you understand. This is the probability is not launched by C. So likewise, now I will explain some more questions on the Bayes theorem. So Bayes theorem should be understand. Okay, I'll explain few more questions on this. Hello dear students, let us continue this question. Now let us see here, a company has, I am giving one more example based on this. A company has two plants. A company has two plants to manufacture scooters. They have two plants. Okay, a company has two plants. Okay, the question is, a company has two plants to manufacture scooters. Plant 1 manufactures 70% scooters, plant 2 manufacture 30% scooter. In plant 1, 80% scooters are rated as standard quality. In plant 2, 90% scooters are rated as the standard quality. A scooter is selected at random and found to be standard. What is the probability that it is from the plant 1? Is asking from the plant 1. Okay, is asking from the plant 1. So here, this is what we called as Bayes theorem. Is asked about from the plant 1. If it is saying what is the probability that found to be standard, means that is total probability. But if it is asking from the plant one, so what you can get as, let us see here, A is equal to selection of standard scooter, and E1 is equal to from the plant one. E2 is, you have to select a standard here. A scooter is selected at random and found to be standard. So event A is selection of standard scooter. E1 is what from the plant 1. E2 is what from the plant 2. Is asking to find what is the probability that it has from the plant 1. So probability of it has from the plant 1 is probability of E1 by A is equal to probability of E1 into probability of A by E1 into, this is the Bayes theorem. Bayes theorem we are going to apply it. So probability of, now probability of see here, probability, what you have to find here, probability of E1 I have to find. E1 means what? Plant 1. What is the probability of plant 1? That you have to find. What is the probability of plant 1 there? It is very simple, no? They are given very simple. Directly they are given. What is that? 70%. 70% means what? 70 by 100. Okay, 70 by 100. That is 7 by 10. So probability of E1 will be, that is 70%, that is 70 by 100, that is equal to 7 by 10. Probability of E2 from plant 2, probability of E2, select probability of E2 will be what? That is probability of E2 they given, plant 2, manufacture from plant 2, that is 30 by 100, that is equal to 3 by 10. Okay, now this is over. Probability of E1 means a company has two plants, manufacture scooter. Plant 1 manufactures scooters. So probability of E1 is 7 by 10, probability of E2 is 3 by 10. Then what is this asking? Probability of event A when E1 already happened. When you have selected from the plant 1, if it is a standard one, okay, standard one selected, that is the given, the plant 1 80% scooter are standard quality. So 80 by 100, this is also given, that is 8 by 10, that is also can be written as 4 table and 5 times 4 by 5 it will get. And probability of standard scooter when E2 already happened, that is E2 happened from the plant 2, how much is they given? 90 by 100, that is equal to how much? 9 by 10. Now what is asking is, what is the probability that it is from the plant 1? Is asked from the plant 1, so plant 1 will be on the top. So probability of E1 when A already happened is equal to, that is standard one in the that is equal to, so E1 is how much? 7 by 10, 7 by 10 into that is A by E1, that is 4 by 5, 4 by 5, and then here it will be 7 by 10 into 7 by 10 into 4 by 5, plus here will be how much? 3 by 10, 3 by 10 into this one is how much? 9 by 10. See what you have to do, simple thing, these questions what you have to do, if you understand total probability, this is over. You know already total probability, whatever is required that you have to keep on the numerator. A plant 1 से बोले तो plant 1 numerator में आएगा, plant 2 बोले तो plant 2 numerator में आएगा, but total probability will be here. Like example, suppose there are 3 bags are there, 3 bags are there. If he has specified the ball is drawn from the second bag, means second bag will be on the numerator and total probability will be in the denominator. I will give you one more example so you will understand easily this point. Okay, so this is what you can simplify this one, anybody can do it, this simplification. You are a mathematics student, so you can simplify that, you will get the answer. That's what the simplest one, as simple. Okay, the answer will be of this one is, I did not solve, you can solve it. Okay, so this is the way we can do it. Okay, fine. You want, if you want I need to simplify, I will simplify, that is up to you. Okay, even though I'll do it. Okay, what is there here? 7 by 10 into 4 by 5 divided by 7 by 10 into 4 by 5 plus 3 by 10 into 9 by 10. See here, 2 table, 2 ones are 2 5s gets cancelled, nothing will be cancelled out, 2 2s are 2 5s gets cancelled, okay, nothing will be cancelled out. Here nothing will be cancelled out. That is, I am getting 14 by 25 divided by 7 to the 14 by 25 plus, and here you just see this is it cancelable any table? No. So 9 3 is a 27 by 100. So just you simplify this, you are going to get the answer. That's it. So here I will get 14 by 25 divided by, here 100 is the LCM, 25 table 4 times you will get 14 4s, you will write 14 4 4 4 is the 16 1 56 56 plus 27. I'll get 14 by 25 divided by, you get as 56 plus 27, 7 plus 6 13, and here 83 by 100. So finally what I am going to get here, 14 by 25 into 100 by 83, and this, at least this much can be solvable, and 25 ones are 25, 4s are gets cancelled out, 14 4s are just now I did 56 upon 83 is the answer.